Hey everyone, I'm Monica Tutor, and today we're going to be starting to review for the AP Physics 1 test. So we're going to be going over just a breakdown of the major concepts: kinematics, Newton's laws, working energy, power, impulse momentum, rotational motion, SHM, all of that stuff. So we'll go through one topic a day. So we're going to start off with kinematics, the first one. Hopefully this all looks fairly familiar to you guys. I would say this is probably the easiest unit of them all. So let's get started real quick with just some quick review. Remember, we always want to break our uh, vectors down to our x and y components no matter what. So that's usually when it comes to our velocity vectors in this unit. We'll have velocity at some angle. So we always want to break down our x and y components, just as what we need to do. Speed. Remember the difference between speed and velocity, and also distance over displacement. Distance and displacement. Speed being a scalar quantity. Hopefully, you guys remember what scalars are, but that's just magnitude with no direction, versus a vector quantity, magnitude and direction. So speed is just more distance over time. So just your path traveled does not matter where you're ending up. It just as long as you're going some distance and some time. So if we were to start here and we would go, let's say, 50 meters this way and then back 100 meters that way, we've in total traveled 150 meters in some amount of time. Versus velocity being your displacement, or your where you are going from your starting position. So let's say this was 100, this was 50 meters. Our displacement would be negative 50 meters from our starting position. So that's kind of what it would be, and it would be negative 50 meters in that amount of time, basically. The same amount of time, but yeah. So that's the difference between velocity and speed, distance, and displacement. And let's get really quickly into our graphs. So position versus time, velocity versus time, acceleration versus time are the graphs that we're going to see the most. Um, you'll notice how these graphs are worked out is we have a curved graph here on our position versus time graph. And you will never be asked to solve for the area of this because this is an algebra-based class, so you can't actually do that without calc. Um, so what this is basically saying, what we can tell by this curve on this graph is that there is acceleration here, and that's highlighted in the acceleration versus time graph. These graphs are all corresponding to each other, and if you take a close look, you will see that this is kind of the position versus time graph, velocity versus time graph, and acceleration versus time graph for something in free fall. So let's say an object thrown straight up, and then that comes down. Um, what we'll notice is the slope of a position versus time graph is velocity. I know we're not figuring out the slope here, but if we had a position versus time graph, something like this, so position versus time graph or something, let's say like this would just mean the slope of this would be the displacement. The slope of this would be the velocity, I'm sorry. So delta x over t, and the area would not give us anything here because delta x times time doesn't give us anything. But once we move to our velocity versus time graph, we'll see our slope will become acceleration because that is the change in velocity over the change in time, and that is what acceleration is. The area under the curve would be velocity times time, which is equal to displacement because velocity is equal to delta x over t. So there's that. Um, since we do have a non-zero acceleration, but it is constant, so we have that, and that's why this graph is curved. If we didn't have any acceleration, the velocity graph would be something more along the lines of this, like a straight line, not changing, and that would make the position versus time graph also become a straight line. So the area under acceleration versus time graph won't it will give you the change in velocity basically, because that is acceleration times time, which is again the change in velocity, but the slope of it is not going to give you anything. I'm sorry about that. Just some quick reminders. Your g will always be 9.8 meters per second squared, always going straight down. That'll become more apparent when we start doing Newton's laws. Obviously, you guys should know all this by now, but this is just some of this review, just making sure you know. The equations for this unit are going to be the ones we have right now, we have listed right here. So we have your final velocity is your initial velocity plus your acceleration times time. Your final velocity squared equals your initial velocity squared plus 2 times acceleration times your change times your displacement. Then we have our displacement is equal to our initial velocity times time plus 1/2 acceleration times time squared. This one is not given on your formula sheet, but it's something you should know just for displacement. And this one is just our simple one, basically. Um, Remember, this is all for constant acceleration. You will not have anything with non-constant acceleration in Physics 1. So let's move on. With projectile motion, so 2D motion, basically, I'm sure you guys are all masters at this now. Something like that, something thrown like that, I guess. You remember you have to split your velocity into x and y components. You always need to do that whenever you're doing projectile motion problems. Your acceleration in the x direction will always be 0. The speed that it's thrown at and starts off with will always be the speed it ends off with. Your acceleration in the y direction will always be your 9.8 meters per second squared. So since our acceleration in the x direction is 0, we have a constant velocity. That's simple. So you will end up using these formulas when in the y direction for projectile motion. But for in the x direction, the only formula you will need is this one because your velocity is the same. So you will only ever need that one, and you have no acceleration. Um, yeah. In Physics 1, you are required to know center of mass. I don't think it's in the kinematics unit, but I'm just bringing it up here. I think I did this honestly in the rotational equilibrium unit with torque and dynamics, but that's fine. We'll bring it up here. Basically, the center of mass is just the center of objects, and kind of what it is in kinematics is the that's kind of when we do kinematics, we are measuring the center of mass's movement. So if we have an object like this is our center of mass. We're actually when we measure the acceleration, the velocity, where it's going, we're measuring where the actual center of mass is going, not the whole thing in general. Um, Sometimes you will have like a system of things. So let's say like 3 squares. Your center of mass would be like here, and we are measuring where this center of mass is going, not where each individual object is going. Um, how to calculate your center of mass? You will only have it on a graph. So you'll have maybe an object here at some point at like 0, 4, and some object like here at like 4, 0 maybe. And you will have to break it up in x and y components, and you would literally just do this formula as written. So the mass of object 1 times the x position of object 1 plus the mass of object 2 times the x position of object 2 over the two masses added up. Obviously, that can be done for as many objects as you need to do. I should have wrote in the end plus mn xn, but it's okay. And the same thing will be done in the y direction, and that those will give you your x and y coordinates of your center of mass. So for here, it would probably be somewhere around here. Um, and obviously, the thing is, that's assuming that these blocks are the same mass. If one becomes one becomes a higher mass, it'll move closer to that object because it'll have a bigger say. Um, that's basically all there is about kinematics. The unit's relatively short. It's pretty simple. And I hope this helped. We'll get into Newton's laws in the next video. Thank you so much, guys.